Hey, eighth grade. Today we are going to be talking about scatter plots and association. You can find your notes, which we will be doing today, on pages 71 and 72. So I'll just kind of write that up here. And at the top of your page, we're going to fill in these blanks here. It says scatter plots are graphs that use points to display. And we're going to have to write kind of small. My pen doesn't do so well with that, so I'm going to kind of do the best I can here. Numerical data with two variables or bivariate data. All that means is that we have two sets of data. Okay. Scatter plots can help determine if one variable has an effect on the other, or if there are overall trends, patterns, or association between the variables. So fill that in there. So here in this scatter plot that you'll see, it says Susie went to the mall and surveyed shoppers to see how many items they'd purchased and the total amount of money they'd spent at the mall. She created the scatter plot below. How many shoppers did Susie survey? Just from looking at this, we can see that there is a point of data here, here, here. So we could essentially just count those points of data, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 points of data. Okay, and the next part says, does the number of items purchased seem to have an effect on the amount of money a shopper spent? Explain. Well, overall, I would see, if you can kind of see that there is a trend with the number of items that you spend, that the cost is going to increase. So overall, it seems that people who bought more items also spent more. So you could write that in. Overall, it appears that people who bought more items spent more. It's kind of common sense, right? Okay, so now, move this around. We're going to erase this, okay, so we can move on and go to the bottom of the page. So we're going to go here to the bottom. Down here it says two variables have positive association when the variables move together. Okay. For example, as one variable increases, the other variable increases. So you can see that in this graph here. It's going in this direction. So as this increases, this also increases. Okay. There's a negative association if when the variables move in opposite directions. For example, as one variable increases, the other variable decreases. So we can see that we're getting over here, we're getting higher, but we're getting lower over here. Okay, so that would indicate a negative association. If there's no association, when the change in one variable has no effect on the second variable, that's what we call something that has, or a plot that has no association. So you can see here there's no rhyme or reason, they're just kind of scattered all over the place, right? So as we think about different scenarios, we can think about the type of association that they might have or that we might expect. For example, the hours a person studies and the number of states they visited. I don't see any correlation there, so there would be no association there, right? How about the hours a person studies and their grade on an exam? Well, that would be the more hours you study would likely mean a higher score on your test. So we would say that's a positive association. I'm going to abbreviate that right there. And letter C, the hours a person studies and the hours they spend watching TV. Well, if you're spending more hours studying, then you're more likely to not be watching as much TV and vice versa. So we would say that's a negative association. So while one increases, the other decreases. Okay. All right, on to the next slide. We're going to kind of zoom in here for a minute. So at the top of your page, it says if a straight line can be drawn to follow the overall trend of a scatter plot, it is linear, right? And we've talked about that word many times in 8th grade math. It's a linear. Basically, it forms a straight line, right? Sometimes not so straight. If the points of data are close together, the association is strong. And I'll show you what that looks like. And if the points of data are widely spread, the association is weak. Okay, so we're going to label each type of association. So the type of association, the strength of the association, and whether or not it is linear. So those are the three things that we need to look at. Now here we see that these points of data are grouped fairly close together. Okay, so we're going to say that the association is strong, right? And we need to see this, well, first of all, we also need to determine what type it is, and I think I mixed those up. But we see that as one is increasing, the other is also increasing. So as we go this direction, it's getting higher, right? And same thing here. So we would call that a positive association as they're both increasing. And we would also consider it linear because it kind of forms a linear relationship. It just looks like we could draw a line down the center of that data and it's somewhat linear. Okay. On this next one, we would say that this is a positive association as well. Okay, we'll just say that's positive. Is it very strong though? Are the data points closely compacted there? No, they're not. So we would say that that's kind of even though it's positive as it's trending upward, it has a positive slope, right? We're going to say it has a weak association. Okay, and we would say also that it's linear. Okay, again, it follows that same kind of pathway. On number 3, kind of has a curvy line, right? We've talked about nonlinear relationships a little bit. So if we look at that though, we need to think about that type of association. Okay, is it positive or negative? Well, it's trending upward, so we would say that that is a positive. As one is increasing overall, the other set of data is also increasing. Let's see if I can get this positive. We would also say it's strong because those data points are still closely related, right? They're super closely compacted. So we would say that that is a strong relationship. But is it linear? Not so much. Okay, so we would say that's non-linear. Okay, does it overall form a straight line? If it doesn't, then it would be considered nonlinear. All right, this next one, it kind of, if you'll notice, it goes the opposite direction. These are kind of opposite of each other, right? So we need to ask ourselves, is it positive or negative? And in our studies of slope, we learned what positive and negative slopes look like, and that looks like it has a negative slope, right? So it would be considered negative. It's strong, those data points are close together, and it's linear. We could essentially draw a line down and have it be somewhat straight. Okay. The next one, kind of the same idea. It looks like it's going trending downward, but it's not necessarily linear. So we're going to say it has a negative association. And it is kind of weak. The data points aren't as close together. And we would consider that non-linear. Okay. And the last one, of course, they're all over the place, right? We don't see any correlation really whatsoever. So we would say there's no association at all. It's weak and nonlinear. Okay? All right, I'm going to erase this really quick. So quickly, if you haven't finished your notes, go ahead and finish those notes, and then we'll go ahead and erase, just so that we can move this up here. I usually do it on a slide so it doesn't matter. But we're going to quickly erase that and move it up. Here we go. So on the second part of that page, it says describe the type of association you'd expect to see between the following variables: a person's height and a person's shoe size. So typically speaking, and of course this doesn't apply to everybody, but we would tend to see a positive relationship. So as a person gets taller, their shoe size generally increases. I mean, if we look at a baby, their feet start out super small, and as they grow and get taller, their shoe size will increase. So we would consider that a positive relationship. Okay, so as a person's height increases, a person's shoe size will also increase. Okay, and if you want to give an explanation there, I kind of didn't write one in there, but you are welcome to do that. And the second one is the number of letters in a person's name and a person's IQ. Well, that doesn't make any sense whatsoever. I would expect there would be no correlation there at all. So just none. It doesn't matter how many letters are in a person's name. That's not going to be what determines a person's IQ, and vice versa. So the next example would be the number of absences a student has and a student's GPA. Well, if you think about it, if a student is gone a lot, if that is increasing, what's going to happen to a student's GPA? Well, that is most likely going to be decreasing. So we would consider that a negative correlation, okay, or a negative relationship there. Okay. All right, in examples 8 through 10, we're going to match each scatter plot with its possible description, and you'll see some of this in your homework today. In the first example, it talks about the temperature outside and the total gallons of gas sold at a gas station. Does that have any correlation? Well, that would probably kind of match more. Well, it could, but not really. There's really no relationship. So we would say that that would fit with this one, because I don't see a relationship here either amongst the points of data. So if we look at the second example, B, the size of a home and the cost of monthly utilities for the home. So the bigger the home, so as that's increasing, the cost of the monthly utilities would also probably be increasing. So we would consider that, so that as the size of the home goes up, so will the utilities. So if you remember that, that is considered a positive relationship. So we would say that would be letter E right here. And then the last one, of course, talks about the altitude of a hiker and the total oxygen level in the air. Well, as the hiker climbs, and if you're not aware of that, the oxygen level will decrease. So as he's climbing, getting higher, as that's increasing, his oxygen is decreasing. So that would show a negative relationship. So that would be letter C right here. All right, guys, you should have all the notes that you need. You're going to go ahead and do the homework pages that follow on pages 73 and 74. Good luck.